Okay, for today's video, we're going to continue with our chapter 3, which is Laplace Transform. So before this, you have your ft, and then you try to find the fs of the ft. For this one, you use the Laplace Transform. You use Laplace Transform to find the fs for ft. Now, what if we have fs, then we want to find the ft for the fs. So what you need to do is to find the inverse Laplace transform. Okay, so for today's topic, we're gonna discuss about the inverse Laplace transform. So the notation for Laplace transform is L Laplace transform of ft is equal to fs. So for the inverse form, we have inverse Laplace fs is equal to ft. So for example, first example, try to find the inverse Laplace of 101 over s. So we will refer to the same table, which is the Laplace table, this table. Okay, so before this, you refer the table from the left hand side to the right hand side. You have the ft, and then you refer what is the fs for the ft. Now you do reverse order. I mean, from the fs, find what is the ft for the fs. So for the first example, you have 101 over s. So from the table, refer to the first row, we have 101 over s. 101 is our constant. So the ft will be the k, which is in this case, we have, for the first example, inverse Laplace for 101 over s is equal to 101. For the second example, what is the inverse Laplace for 3 over s minus 7? So refer to the table. So this is, since we have s minus 7, we have here 1 over s minus a. So our a is 7. So for this one, you have 3 inverse Laplace of 1 over s minus 7. So the ft, the inverse Laplace for this fs is 3 exponent, our a is 7, so 3 exponent 7t. Okay, now move to the third example. For the third example, try to find the inverse Laplace of 2s over s square plus 4. So this becomes 2 inverse Laplace of s over s square plus 4. So from the table here, it looks like cos at, where our a is 2. So for this example, our ft is 2 cos 2t. Okay. Next, we have linearity property of inverse Laplace transform. If inverse Laplace of fs is equal to ft and inverse Laplace of gs equal to gt with constants a and b are constants. So you have two functions, fs and gs. So the inverse Laplace for a fs plus b gs, products of constant a with first function and plus b with second function, is equal to a, the constant. Then try to find inverse Laplace of fs plus with b inverse Laplace of gs. So you have a ft plus b gt. Okay, so for the example, we have two examples here. For the first example, we have 1 over s square plus 16 plus 20 over s. Okay, so you have plus here. And then what is, so the inverse Laplace, we try to find the ft, the inverse Laplace of 1 over s square plus 16 plus 20 over s. So this is inverse Laplace using the linearity properties. So this is inverse Laplace of 1 over s square plus 16 plus 20. Inverse Laplace of 1 over s. Okay. So what is inverse Laplace for 1 over s square plus 16? So we have, since we have 1 as a constant, so we have sign here, sin at, which is a over s square plus a square. So this is, you need to modify this fs. So for this one to be in sin at, the numerator should be 4, because this is 4s square plus 4 square. Okay, so this is sin for t, because we have a s square plus a square. But you just change this fs. I mean, from here we have 1 over s square plus 16, but now we have 4 over s square plus 4 square, which is 16. So what you need to do is to multiply this with 1 over 4. So that we have 1 over s square plus 4 square, 16. So because this can be cancelled out. Okay, so plus with 20. What is inverse Laplace for 1 over s? So this is constant. So 1 over s is 20. Laplace, inverse Laplace for 1 over s is 1. Is k. So next, you have 1 over 4. 1 over 4 is your constant. And then you need to find the inverse Laplace for 4 over s square plus 4 square, which is, this is the inverse Laplace for this one is sin 4t plus 20. So this is our final answer, the last answer. Okay. For the second example, okay, try to find the inverse Laplace for 1 over s cubed minus 2 over 3s squared. Okay, so the ft is equal to inverse Laplace of 1 over s cubed minus 2 over 3, again the linearity properties, inverse Laplace of 1 over s square. So from the table, the first fs, we know the first fs, which is 1 over s cubed. So this looks similar to the Tn, where you have n factorial over s n plus 1. So for this one, you have L2 factorial over s2 plus 1. And then again, since you just modify this fs, so you need to make sure it becomes the same one again. So you need to multiply by 1 over 2 factorial minus 2 over 3. Inverse Laplace of this 1 over s square is 1 factorial over s 1 plus 1. So you don't have to change anything. Okay. So try to solve this. 1 over 2 is a constant. 2 factorial is 1. 2 factorial is 2. So inverse Laplace of 2 factorial over s cubed minus 2 over 3 inverse Laplace of 1 factorial over s square. So 1 over 2, 2 factorial over s cubed is t square. While inverse Laplace for 1 factorial over s square is t. So that's it. The last answer for this second example. Okay. So next, we have first shifting property for inverse Laplace transform. If inverse Laplace of fs is equal to ft with alpha as constants, then inverse Laplace for fs minus alpha is equal to exponent alpha t ft, or we can write as inverse Laplace fs minus alpha equal to exponent alpha t inverse Laplace of fs. So for example, we have 3 examples here. Let's try the first one. Okay. So for the first one, we have fs equal to 6 over s minus 2 to the power of 4. Okay. So first, write your fs in terms of gs minus alpha. So you have gs minus alpha, your alpha is 2, is equal to 6 s minus 2 to the power of 4. Okay. So your alpha now is equal to 2. Then what is your gs? From here you have gs minus 2. Now write your gs. So this gs minus 2 become 6 over s to the power of 4. Okay, substitute s minus 2 with s. So you have your alpha equal to 2, your gs is equal to 6s over 4. So the inverse Laplace for 6s minus 2 to the power of 4 is equal to exponent your alpha is 2 exponent alpha to alpha t, and then find the inverse Laplace for 6 over s to the power of 4. So exponent 2t, you have 6 s to the power of over s to the power of 4. So this is inverse Laplace of 3 factorial, since 3 factorial is equal to 6, and then this is s3 plus 1. So referring to your table, 3 factorial over s3 plus 1, this is t to the power of 3. So your last answer is exponent 2t t cubed. Okay. Move to the second example. Okay, we want to find the inverse Laplace of 3 over 2s plus 7 cube. So for this example, since for the first shifting properties we need to have f s minus alpha, but now you have 2s plus 7, so you need to get rid of the 2 here. So first what you need to do is divide everything with 2, so you have s plus 7 over 2 cube, and then you move out your 2, then these 2 have cube here because you have cube. Okay, so you have 3 over 2 cube s plus 7 over 2. So now you have 2 cube is equal to 8, multiplied by 1 over s plus 7 over 2 cube. Okay, and then try to find the inverse Laplace of this function. Okay, the inverse Laplace of 1 over s plus 7 over 2 cube. Okay, so from here, s minus alpha, so your alpha here is minus 7 over 2. Your g, s minus 7 over 2, your alpha is equal to 1 over s plus 7 over 2 cube. Okay, so what is your gs now? So gs become 1 over s cube. Okay, so next, the inverse Laplace of 3 over 2s plus 7 cube is equal to 3 over 8. Okay, 3 over 8 inverse Laplace of 1 over s plus 7 over 2 cube. Okay, using the first shifting properties, now you have your alpha equal to exponent, your alpha equal to minus 7 over 2, so you have exponent minus 7 over 2 t, and then find the inverse Laplace for this gs, which is 1 over s cube. So what is inverse Laplace for 1 over s cube? Can we directly see from the table, or do we need to modify it? Okay, so the answer is to modify this fs. So in order for this one to be t square, you need to have 2 factorial here. So this is t square. Inverse Laplace for this function is t square. So because you have 2 factorial here, you need to multiply by 1 over 2 factorial. Since our gs is 1 over s3, not 2 factorial over s3. So next we have 3 over 8 exponent minus 7 over 2t. You have 1 over 2 here, and inverse Laplace for this one is t square. So the last answer is 3 over 16 exponent minus 7 over 2t t square. Okay, then we have the last example here. The third example here, we have to find the inverse Laplace for 6 over s square minus 2s plus 5. Okay, So your fs is 6 over s square minus 2s plus 5. So refer to the table. Is there any quadratics for the denominator? Yes, you have. For cos and sine, but it just s square plus a square. You don't have any complete quadratic function, quadratic equation, which is we have a s square plus bs plus 5. So for this example, what you need to do is to do the completing the square method for the denominator. So for completing the square, okay, completing the square, when you have a y square plus a quadratic equation, which is a y square plus by plus c equal to 0. Okay, so this one, to complete the square, you have y plus b over 2a square plus c over a minus b over 2a square equal to 0. Okay, completing the square. You need to remember this for the shortcut. Okay, so let's try this. You have your fs equal to 6 over s square minus 2s plus 5. So this one becomes, you have 6. What is your a? A is 1. B is minus 2. And C is 5. So substitute here, you have S plus B. Your B is minus 2. Divide by 2A. 2 multiplied by A is 1. So you have 2. You have square plus C over A. 5 over 1. Which is 5, minus b minus 2 over 2a. Again, we have 2 multiplied by 1 square. So this is 6 over s minus 1 square plus 5 plus minus 2 over 2 is minus 1, square is positive 1. So you have minus 1. Okay, so this is 6 over s minus 1 square plus 4. So now you have s minus 1 square plus 4. You can write this as s minus 1 square plus 2 square. So now you have your fs equal to 6 over s minus 1 square plus 2 square. Okay. So what is your alpha? Alpha is equal to 1. Okay, so your GS is equal to 6 over s square plus 2 square. Okay, modify your GS, because for GS, for this one to be sine 2t, you need to have 2 over s square plus 2 square. So this is sine 2t, but you have 6 and then you need to divide by 2. Okay, so this is 2 over s square plus 2 square. So the inverse Laplace for 6 over s minus 1 square plus 2 square is equal to, since alpha is 1, so you have exponent t. And then inverse Laplace of your gs, which is 2 over s square plus 2 square. Okay, so you move your 3, exponent t. Inverse Laplace of 2s square plus 2 square is sine 2t. So the last answer is 3 exponent t sine 2t. Okay, the last subtopic for inverse Laplace is convolution theorem. We have the convolution theorem where we use when we have to solve for inverse Laplace of a product of two functions. I mean, if you want to find the inverse Laplace for fs multiplied by gs. Okay, so previously we solved for fs plus gs, fs minus gs, the linearity properties. Now what if we have fs dot gs? So the convolution of ft and gt, the inverse Laplace, denoted as f star g, is defined by f star g equal to integration from 0 to t fu g t minus u du. So for the convolution theorem, you need to solve for integration from 0 to t. Okay, so this is the theorem. The theorem said, let ft and gt be piecewise function continuous on 0 to positive infinity. Okay, set fs to be equal to Laplace of ft, and gs is Laplace of gt. Hence, Laplace for ft gt is equal to fs gs. Or we can say that the inverse Laplace of fs gs is equal to ft gt, which is from previous ft gt is integration from 0 to t fu gt minus u du. Okay, let's see the two examples here so we can understand more on convolution theorem. So first example, okay, for the first example, how we solve for convolution theorem. Let's say you have 1 over s square plus 9. Okay, the first things to do is to set your fs and gs. What is your fs? What is your gs? Okay, let's say your fs is equal to 1 over s square plus 9, and your gs is 1 over s, because this is a product of 1 over s and 1 over s square plus 9. So fs is 1 over s square plus 9 and gs is equal to 1 over s. Second, find the inverse Laplace of both fs and gs. So find the ft and gt. So what is the inverse Laplace of 1 over s square plus 9? So this is sine t. You know sine t. So for sine t, you have a here. So a is 3. So this is 3s square. So you need to find the inverse Laplace of 3s square plus 3 square multiplied by 1 over 3. Okay, so we have 1 over s square plus 9. So the inverse Laplace of this is 1 over 3. This is sine 3t. Okay, you have 1 over 3, the constant, and then you find the inverse Laplace of this one, which is sine 3t. Then the GT. What is the GT for 1 over S? So GT for 1 over S is 1, the constant. Okay, so now you have FT and GT. The next steps is to find the FU, because from the theorem we need to do the integration for FU and GT minus U. So for FT, write your FU. So this is 1 over 3 sine 3U. Instead of T, we substitute to U. And while for the G, we have GT minus U. So for this case, GT minus U is equal to 1 as well. And then the inverse Laplace is 1 over S squared plus 9 is equal to, apply the integration from 0 to T, substitute your FU, 1 over 3 sine 3U, and then substitute your GT minus U. This is 1, then you have DU. So basically this is just 0 to T, 1 over 3 sine 3U du. Okay, so solve it. Solve the integration. 1 over 3 integration for sine 3U is cos 3U, sorry, minus cos 3U over 3. It is from 0 to T, so you have 1 over 9 here. Then you have, you need to substitute the limit, upper limit and lower limit. So this one you have cos 3T minus cos 0. So this is 1 minus 1 over 9 cos 3T minus 1, since cos 0 is equal to 1. Or you can write this as 1 over 9, 1 minus cos 3T. So this is for the first example. Okay. Second example. For the second example, we have to solve for 2s over s squared plus 4 squared. Okay. Again, we start with determine what is, setting what is our Fs and Gs. Okay, so you have this one. So this is basically a product of products of 2 over s squared plus 4 and s over s squared plus 4. So this can be written as plus 4 multiplied by s over s plus 4. So let's say Fs is equal to 2 over s plus 4. And then Gs is s over s plus 4. And then find the Ft. Okay. Ft for 2s plus 4. Sorry, this one s square. S square, S square, S square. So this one is, Ft for this one is sine 2t. While for GT is cos 2t. Because you have s square plus 2 square. You have 2 here. So this is sine s square plus 2 square. This is s. So this is cos 2t. Okay, so you have Ft, Gt, then find Fu. Fu is sine 2u, then Gt minus u is cos 2t minus 2u. Okay, substitute t with t minus u. So you have 2t minus 2u. Then substitute into the convolution theorem. Sorry, this is 2s. s square plus 4 square is equal to integration from 0 to t sine 2u from fu multiplied by cos 2t minus 2u du. Okay, so you have sine 2u cos 2t minus 2u. Okay, how to solve for this integration? Okay, so you need to refer to the trigonometry identity. You have sine and cos, products of sine and cos. So refer to row number 10. 2 sine x cos y equal to sine x plus y plus sine x minus y. So apply this identity to this one. So now you have here 0 to t 1 over 2 sine 2t plus sine 4t minus sine 4u minus 2t du. Okay, from here to here you need to use the trigonometric identities. Okay, so you have 1 over 2 0 to t sine 2t plus sine 4u minus 2t du. Okay, do the integration. Okay, integrate respect to u. So sine 2t becomes u sine 2t plus sine 4u become minus cos 4u over 4 4u minus 2t over 4 from 0 to t. Next, substitute your u with t. So here you have t sine 2t minus cos 2t over 4, then minus 0 plus, substitute u with 0, you have cos minus 2t over 4. So this is equal to 1 over 2t sine 2t. What happened to plus cos minus 2t over 4? This cos 2t over 4 is equal to 0. So there is no value for this term. Okay, so this is how you do the convolution theorem. You solve for convolution theorem. So that's all for inverse Laplace transform. Okay, so for next video we continue with solving the initial value problem using Laplace transform.